All right, let's start joining the class. We are already live. Let's start joining the class. We are already live. Please, let's start joining the class. We are already live. Let's start joining the class. Okay, so I think it's a good time to start. So the rest, and it does not look like we are going to start today. How many of you are in this class? Just about 2 of you. As you enter, as usual, you register your presence. Yeah, goody, Dalu too. How are you? Register your presence, write your attendance. Okay. So that we can start. Okay, so we're almost 30 minutes late. So, but it's remaining 4 minutes for it to be 8 o'clock. So, let me assume that I'm going to give you people 4 more minutes. So that every other person will join the class. So please share the link in your other groups, where you are. Let your mates join the lesson. There is no time, like I've said, so that okay. All right. Okay, 2 more minutes is 2 minutes to 8, so 2 more minutes. Please, if you are on the WhatsApp group, you can keep typing there for them to join. I'm no longer there now. All right. Okay, so it's just 1 more minute to the class. So, and I think I should start now to my recording here. Did I press? Okay, so please, as you enter, as you drop your name and your department, also give a thumbs up to the particular class. It helps the algorithm of our lesson. And then please, okay, anyway, okay, so let's start. All right, so in our last class, good evening everybody once more. In our last class, we started discussing about partial fractions. Yeah, Nazar, good evening, good evening. Okay, Monachi, good evening. Okay, so and then we said that a partial fraction or partial fractions is just the set of fractions that you can get by breaking down a given fraction into smaller ones. Okay, so we saw some examples. One of the examples you can see is, for instance, where I said if you have something like 1 over x plus maybe 2x all over okay, let me not use that 2x there. Okay, say 2 all over x plus 1. If I join this now, I'm going to have x into x plus 1, and that's going to give me x plus 1 then plus 2x, okay, which is equal to 3x plus 1 all over x into x plus 1. Okay, so here now we can say that this is the single fraction, while these two are the partial fractions of this guy. Okay, right, so that was what we discussed. What is happening? Where are the rest of the members of this class? Where have they all gone? If we are not ready for this night, we can actually move the class to another time. Okay, I'm seeing just 2 persons in the class. So if it's not this thing for today, we can move it. But then let's still continue. They will come back anyway. Maybe they have bad networks. Okay, so let's go on. So here now, we discussed in that class that you can have distinct linear. We can have distinct linear denominators, and then we also saw that you can have repeated linear denominators. And we said for repeated linear denominators that for the 2 of them, they follow a particular pattern. Okay, so and then we're able to do one or two things, one or two examples there. Okay, so maybe I should take one example, should I? And then before we get into today's own. All right, let me check from my exercises. Maybe we can find a good example that we can see. Okay, I'm seeing one here, but that one looks a little big. Okay, so let me leave that one. Okay, maybe that's the only one I have here. All right, let's look at it. So here we are given, let me call it example 1. So we are given, where is it again? 3x, okay, plus x again. I think this should be 3x squared, then plus say x, and then plus 1 all over all over x minus 2 into x minus 1 raised to the power of 3. Okay, so here we saw that that this is going to give us, of course, we are going to break it down. And what are we going to break it down into? So here you can see we have about 4 factors here, x minus 2 and then x minus 1 repeated into 3 times. Okay, so that means we are going to have 4 fractions here. These were the things we saw in that last class, that the number of denominators, linear denominators, will tell you the number of fractions. Okay, so here we are going to have x minus 2 plus, here you will have x minus 1 plus, the next one will be x minus 1 raised to power 2, and then the last one will now be x minus 1 raised to power of 3. Okay, so you keep moving from 1 to 2 to 3 until you have captured all the powers that are there. Okay, so because we are dealing with linear denominators, all their numerators are going to be constants. So you will have a, b, c, d. So what that means is that we are looking for 4 constants. So we are looking for a, b, c, and d. All right, so and we can start by getting our LCM. All right, so if we get the LCM, okay, let me use my ruler. So if we get the LCM for this, what that is going to give us is okay, so it's going to give us the same thing that we have here, which is x minus 2 into x minus 1 raised to the power of 3. Yeah, Judith, okay, you are welcome. All right, so let's start. So if x minus 2 divides, you have only x minus 1 raised to the power of 3 left. So here you have a into x minus 1 raised to the power of 3. Then you bring down your plus. You can also bring down your b. So x minus 1 will divide. It will cancel only 1. So 2 will be left. So you will have x minus 2. And under here you will have x minus 1 raised to power 2. Okay, I should have shifted this in a little bit, but let's go on. So you bring down your c. And then here now, x minus 1 raised to power 2 will divide. It will cancel 2 here. 1 will remain together with this one. So you have x minus 2 into x minus 1. Then finally, let me reduce. Okay, so finally there, we are going to now have, okay, let me try moving this to this side. All right, so here we are now going to have, I can increase this, plus d will now come down. If x minus 1 raised to power 3 divides, you are going to have x minus 2 only. So here will be x minus 2. Okay, so why am I doing this example? you can see this example, the ones we did previously, they have just about, we did the one that has 2 denominators, we did the one that has 3. So we are doing this one now, it has 4. Okay, so let's go on. So our job now, we can bring down this, but in doing that, we can now cancel the equal denominators. So we'll just bring down the numerator. So you have x squared plus x plus 1, okay, is equal to, so you bring down the whole of this, which is a into x minus 1 raised to power 3 plus b into x minus 2 into x minus 1 raised to power 2 plus c into x minus 2 times x minus 1, then finally d into x minus 2. Okay, so this is what we have to solve to get our ABC. Alright, so how do we do that? Remember, we have been using the method of substitution. So here, let's assume we want to get A. Okay, so to get our A, you can see that to get A here will be a little bit difficult by substitution, because the only thing you can substitute here, okay, yeah, it will work. There is x minus 2 here, x minus 2 and x minus 2. So that means I can let my x be equal to 2. And if I do that, these 3 terms here will all be eliminated. So we'll just have x into 2 raised to power 2. I'm substituting now. And then this is plus 2 and plus 1 is equal to, so here you will now have a into 2 minus 1 is 1 raised to power 3, while inside your b will turn to 0, your c will turn to 0, and your d will turn to 0. So no point writing those ones. So here we'll have 2 raised to power 2 is 4, 4 times 3 is 12, plus 2 is 14, plus 1 is 15. So you have 15 is equal to a, because 1 raised to power 3 is 1, and 1 times a is still a. So we have gotten our a to be equal to 15. Okay, so what's the next thing you think we can get here? I hope that we are ready to participate here. What's the next thing you think we can get by substitution? What is it? What is it? Here you can clearly see that the only other bracket that is common is x minus 1. X minus 1 is with A, is with B, and is with C. So that means the only other alphabet I can get by substitution will be will be my D. Because, why did I say so? Because if I now substitute my x as 1, is going to eliminate A, B, C, and then you can get your D. So let's quickly do that. So if we put our x as 1, we are going to have 3 into 1 raised to power 2, so plus 1, and then plus 1, and this is going to be equal to, so if we put x as 1 here, A will go. If we put x as 1 here, this will turn to 0, B will go. If we put x as 1 here, C will turn, this will turn to 0, and C will also go. So we will only have D into 1 minus 2. That's here. Okay, so from there now, we are going to have, okay, if you open this bracket, 1 squared is 1 times 3 is 3 plus 1, that will be equal to 5. And then this is 1 minus 1, which is, 1 minus 2, which is minus 1, and minus 1 times D is minus D. So that means that our D alone is going to be equal to minus 5. Okay, so we have gotten A and D. To get the other ones. Alright, let me bring down the whole of this term that we have here. Let me try bringing it down. Okay, I hope it will not cut. It has cut. Okay, let me raise my hand a little bit. Okay, so I'm trying to bring down what we have. Okay, paste it. So where did it paste? Okay, I'm not seeing it. All right, so since it's giving me continue, okay, I can just with it. Okay, so what are we going to have now? Our job now is to get our B and our what do you call it, and our C. Okay, so now the only way, there are two ways that you can get B and C now, and one way is to open the whole bracket and begin to use equivalent fractions that equivalent polynomials that I taught you earlier on. But that's going to take your time. So what else do you think we can do? And I said something in the last class that in such cases you can substitute your x as 0. Okay, so if we let our x become 0 now, what is going to happen? Let's look at it. So if I put x as 0 here, the whole of this will turn to 0. This one will turn to 0. So I will just have 1 is equal to, here now, you are going to have, there you are going to have, this will become a into 0 minus 1 is minus 1 raised to power 3. Then plus b into, this one will become, of course, here will be 0 minus 2 will be minus 2. And then here again, 0 minus 1 will be minus 1 squared. Then we go to c. C will become 0 minus 2 is minus 2. And 0 minus 1 is minus 1. And finally, we go to d. So d is going to become 0 minus 2, which is what? Minus 2. Alright? So from here, you are now going to have that 1 is equal to, this is minus 1 raised to power 3, which is minus 1. And that will give us minus a. Now here, minus 1 squared is 1. 1 times minus 2 is minus 2. So you have minus 2b. Okay, so we have minus 2b. While here, we are going to have minus 1 times minus 2, which is 2. And that's going to give us 2c. And finally here, we will have minus 2d. Okay, so but already we have the values for a and d. Okay, and so we can substitute here. So we have 1 is equal to, our a is minus, is 15. So that means this is going to be minus 15. Then we'll have minus 2b plus 2c. And we also have our d. And our d is minus 5. So minus 5 times minus 2 will give us plus 10. So this is going to be equal to minus 15 plus 10 will give us minus 5. So we'll have minus 2 plus 2c. Okay? So if we move minus 5 to this side, we are going to get 6 is equal to minus 2b plus 2c. Therefore, our first equation will be minus 2b plus 2c as equal to 0. Alright, so what are we going to do with that? So we will now try to also do another substitution to see if we can get another equation. Okay, so which other substitution do we think we can do here? Okay, so we can actually maybe try x as any other thing, maybe minus 1. Okay, so let's make our x minus 1. So if we say let our x be minus 1, maybe that will also help us get the second equation that we will use to solve together with this. Remember that we can call this equation 1. Okay, so if we make our x minus 1, so from here, we are going to have 3 times minus 1 squared minus 1 plus 1. So let me write it here. So we'll have 3 into minus 1 squared, then minus 1 plus 1. I think that's what we have there. Okay, yes, it's going to be equal to, okay, it's going to be equal to our A is multiplying x minus 2, sorry, x minus 1, and x minus 1 is going to be minus 1, which will give us minus 2 raised to power 3. Okay, so is it equal to 0 or 6? Thank you. Sorry. Thank you. Is equal to 6. Yeah, Patrick, thank you. Yeah, that's good. Okay, so is an oversight. Okay, so the next one we are now having, okay, so here we are now substituting minus 1, and so this is going to give us minus 1 minus 2 is minus 3, and minus 1 minus 2, sorry, minus 1 minus 1 will be minus 2. So we have plus b into minus 3 times minus 2 raised to power 2. Okay, so we now go to C. So in the case of C, we are going to have minus 1 minus 2, which is minus 3, multiplying minus 1 minus 2, which is minus 2. Okay, and then finally this one will be minus 1 minus 2, which will be minus 3. Okay, so let's go down. So this is going to be minus 3 minus 2, and then plus d is minus 3. Okay, so let's try to simplify. So this is going to give us minus 1 squared is 1, and 1 times 3 is 3. Okay, so this one will cancel out. So we just have 3 here is equal to, now here you have minus 2 raised to power 3, which is the same thing as minus 2 times minus 2 times minus 2. And that will give us minus 8a. Then we come over here. So in this case, we are going to have minus 2 squared, which is 4. 4 times minus 3 is minus 12. So we'll have minus 12b. Okay, let me remove this. Alright, so the next one is going to be minus 3 times minus 2, which will give us plus 6c. And finally, we'll have minus 3d. Okay, so we will do the same thing we did in this place by substituting our a and d. So our a is, what did we get as our a? 15. Okay, so 15 times minus 8 is going to give us minus 4 times 30, which is minus 120. Okay, then here we don't know our b, so we leave it, and we don't know our c, we also leave it. Here we know our d, and our d is minus 5. So if we substitute here, minus 5 times minus 3 will give us 15. Okay, so we are now going to have 3 is equal to minus 120 plus 15. Okay, meanwhile, if you watch carefully, you see that 3 can divide through everything here. Is that possible? Yes. If 3 divides 3, we get 1. If 3 divides 120, we get minus 40. If 3 divides 12, we get 4b. If 3 divides 6, we get 2c. If 3 divides 15, we get 5. This is just to reduce the equation so that it will not be too high. Okay, so this is now going to give us, take all the constants to this side. This one plus this is minus 35. And minus 35 coming here will give us 36. Is equal to minus 4b plus 2c. And if you watch, you see that 2 can still divide through. But it will be good that we leave it like this. And why did I choose to leave it like this? Because I'm also seeing 2c in equation 1. So that we can eliminate those 2. So we can call this equation 2. And so we can solve the 2 of them simultaneously to get our ABC. Okay, so permit me to now bring, or should I just reduce here? I wanted to take this to another to another page, but let's just reduce it and solve here. Okay, so if you are still with me, please let me know. Just give one emoji, let me know you are following me. So now we have two equations to solve. So the first one is minus 2b plus 2c is equal to 6, and the second one is minus 4b plus 2c is equal to 36. Okay, so and what do? Elimination can go here. All right, let me change my marker at this point so we can subtract. So minus 2b minus 4, minus 2 minus 4 is going to give us minus 2 plus 4, and that is equal to 2b. Okay, and 2c minus 2c will be eliminated, equal to, then we now have 6 minus 36. That is going to give us minus 30. Okay, therefore our b is equal to minus 15. All right, so finally, to get our c, we can substitute into any of the equations. Maybe we can do it up here. So if we substitute our b as minus 15, that is going to give us minus 2 times minus 15 plus 2c is equal to 6. I'm substituting in equation 1, and so that's going to give us 30 plus 2c is equal to 6. And so our 2c is going to be 6 minus 30, which is going to give us minus 24. Therefore, our c alone is equal to minus 12. Okay, so I just decided to finish up here. So we have gotten our A, B, C, D. We have gotten our A, B, C, D, and we can finally substitute into the original fraction that we have here. Therefore, our partial fraction is going to be, our A is 15, so we'll have 15 all over x minus 2. Then our B, what did we get as our b? Minus 15. So that's going to give us minus 15 all over x minus 1. And then our c we got minus 12. And that is going to be minus 12 all over x minus 1 squared. And finally, our d is minus 5. And that is going to be minus 5 all over x minus 1 all raised to power 3. Okay, so and that is the solution. I am sorry that I had to give you this long example. Very sorry about that, but I want to believe that you understood it. And if you have any issue, you can let me know. Okay, so that's the solution for this one. All right. So, and I just used this to do a review of what we did earlier on. Okay, so we just did a review of the last place where we stopped. Okay, so and that's where we will stop for here. So we will now try to look at the next type of partial fractions. But if there is any question, you can let me know. And what is the next type? That is when you have quadratic roots. Okay, so that's the C. Okay, Munachi is there. So you can have quadratic roots. Remember quadratic denominators. Okay, remember I said that the quadratic denominator can, just as you have under linear, it can be repeated or distinct. So for this one, we are looking at distinct quadratic denominators. So what if your denominator is not what if they are not linear? What if they are quadratic and they are distinct quadratic denominators? what do you do? Okay, so quickly let's look at some examples so that we will know how to handle distinct quadratic roots. Okay, so look at this example. Let me still call it example 1 for this. So here we have 2x squared minus x plus 3 all over here we have x plus 1 into x squared plus 2. Okay, so now this case now, all right, Patrick, that's okay. So I'm only seeing 2 persons being active in this class, and I don't know what happened to the rest. Please, you can let me know whether you have question or you did not follow or not, so that I will know if I should repeat anyone. Okay, so now if you watch here, you will see that here you have a linear denominator and a quadratic denominator, and the only place where we usually bring in this quadratic approach is when the quadratic denominator cannot be factorized. For example, if you consider x squared plus 2, you see that we cannot factorize this into any linear polynomials. And so when it happens that way, then you will need to now have a quadratic denominator. Okay, so let's look at that. So here it means that you are going to have 2 denominators, that's 2 fractions. Okay, so the first denominator will be x plus 1, and the second denominator will be x squared plus 2. Okay, so when you have something of this nature, how do you simplify into their partial fractions? Now I have already splitted, so the question now is, what is going to be my numerator? So this one, the denominator is linear, so the numerator will be a constant, so we can use a there. Now we go to the other one. The denominator is quadratic, so the numerator is going to be linear. Remember I said that the numerator is always, the degree is always 1 less than the degree of the denominator. So here the degree of this constant is 0, while the degree of the denominator is 1. Here now the degree of the denominator is 2. Therefore, the degree of our numerator should be 1, and that is why it is supposed to be linear. So this is what you're going to write as your numerator, bx plus c, or you can use any alphabet of your choice. You cannot use a again because you have used a here, so you can use maybe d or whatever. You can use dx plus c. The only thing is that you will introduce x so that it will be linear. Okay, Nazar, I can see your presence. All right, so you will introduce d so that x so that it's going to be linear. All right, so now let's try to solve this now. So this is just the only difference for quadratic, nothing more. The same thing we did under linear, that's what we are going to do here. Okay, so the only difference is that your numerator should be linear, while for a linear denominator your numerator should be a constant. Okay, so let's go. So we still look for LCM here, which is still the same denominator here, which is x plus 1 into x squared plus 2. Okay, so let's start our division. X plus 1 will divide, so you have a multiplying the other one, which is x squared plus 2. Then you bring down your addition sign, and so here you will now have x squared plus 2 will divide. So you bring down this numerator. You can see I'm putting this numerator in brackets. Why? Because there are 2 of them there. So you put a bracket. So, and then you now multiply it by this one that is left, which is x plus 1. Okay? So, and that is all. So you cancel out equal denominators, just as we did under linear. And then you will now bring down the numerators. So you have 2x, don't mind me, 2x minus x plus 3 will be equivalent. You know I've been using equal to. This thing is supposed to be equivalence. Okay, so will be equivalent to a into x squared plus 2, then plus bx plus c into x plus 1. Alright, so once you have gotten your numerators, then you will now try to start solving. So how many constants are we looking for here? We are looking for 3 constants. Once you get the 3 constants, you will now substitute into these particular fractions here, and that will be your answer. Okay, so let's quickly go there. Alright, so meanwhile, I am just explaining these repeated roots, denominators. If you have followed me up to this point, you can also show a sign that you have. Okay, so what do? You can also use method of elimination here, that's substituting something. Okay, so for instance, if I want to get a now, I can find a way to eliminate this b and c. And for me to eliminate this b and c, all I need to do is to make this guy 0. Okay, so once I make this bracket 0, it will cancel the whole of this. And of course, that is easy. So to make it 0, I'll just make my x to be minus 1. Alright? Okay, Pat, that's okay. Alright, so let's go. So if I make my x to be minus 1, so this is going to become minus 1 squared is 1 times 2 is 2. So you have 2 minus 1 will be plus 1. Okay, then plus 3 is equal to, here you will now have minus 1 squared is 1. So you have 1 plus 2. And then the whole of this will turn to 0. So no need writing it. Okay, so here I'm now going to have, this will give me 6 is equal to 3. My a alone is equal to 2. So I have gotten the value of a as equal to 2. So the next thing now is to now get my b and c. And what's my b and c going to be? Let's try to check. Okay, so is there any other way we can eliminate? There's a problem, and that's not a big issue, sha. Okay, so because you cannot eliminate a here. Alright, so but you can try to eliminate b, and if you eliminate b, then you will have a and c, but you already have value for a, then you can substitute it and use it to get your c. Okay, why is x 1? Is it 1 or minus 1? Okay, x is minus 1 because it will help me eliminate this one. If you put minus 1 plus 1, that will be equal to 0. So it will help me eliminate everything here and then help me to get the value of a. Naza, I hope you understood now. Okay, so let's go on. So here, see what I'm saying. I can eliminate this b by making my x to be equal to 0. And if I make my x to be 0, the whole of this will turn to 0. This will be 0. So I will just have only these 3 on the left hand side. So I will have 3 is equal to, on the right hand side now, this one will be 0. So I will have 0 plus 2, which is 2. And 2 times a will give me 2a. Then if I now come here, so this b will turn to 0 because my x is 0 and b times 0 will be 0. But my c will still be there because 0 plus c will still be c. So I will have c multiplied by, if I now put my x as 0 here, I will have 0 plus 1, which is 1. So watch what will happen there. So I'll have 3 is equal to 2a plus c. But I know the value of my a. And what is my a? My a is 2. So I'll have 2 times 2 plus c. Alright? And then immediately I am going to have that my c is equal to 3 minus 4, which will give me minus 1. Okay, so I hope you have also followed me, everybody. Okay, so finally, how do we get our b? How do you get your b? Now you can get your b by expansion, and or you can get it by doing another substitution. Munachi, that's okay. All right, this time around I want to use expansion, so let's try to expand. So this is going to give us 2x squared, okay, Naza, you're welcome, plus 3 is equivalent to, if I expand this, I'm going to have ax squared plus 2a, then plus here, if I expand this one, bx will multiply x, and that will give me bx squared. Bx will multiply 1, and that will give me bx. Then c will multiply x to give me cx, and c will multiply 1 to give me c. Now watch what I want to do now. What I want to show you now will really help you to know that even expansion is not as difficult as you think. Okay, so why did I expand here? Because I've already gotten at least a and c, so it will help shorten my expansion. So now I am looking for only b. So I will look for the only part that concerns b, and there are two parts that did that. The square, let me use white now. The square did it, the square connected to b, and the x alone connected to b. So you can use any one. Alright, so watch what I am saying. If I gather the squares here, I'm going to have a plus b into bracket x squared. Am I correct? Yes. Watch what I'm saying. I don't need the rest. So all I now need to do is pick the coefficient of x squared and equate it to the coefficient of x squared here. And that will give you a plus b equal to 2. So why did you do that? You already have your a, and that is 2. So you have 2 plus 2 is equal to 2. Therefore, our b is going to be equal to what? 0. Alright? Sir, did you substitute the minus 1 into x? Yes. You substitute it everywhere. You put it everywhere. Look at it here. I did that. When I substituted it here, I got 0. So that's why I didn't bother putting it here. Monachi. Okay? So there's no point putting it into bx plus c, because by the time you put it in this bracket, you will get 0. And this bracket is multiplying this bracket. And so 0 times this will turn to 0. So even if you put it here, you will just get minus b plus c. And 0 times this will still be 0. So no point delaying yourself. I hope you got what I just said now. If you did, respond to it. Okay, so let's go on now. So back to what I was trying to explain here. So here now we have gotten our b to be 0 by using only x squared. Now another person, let's assume that it's Monachi that did this. Another person, Peculiar, you're welcome. Another person may choose to use x. You know, x also connects to b. Sir, please, I don't know how the 0 now has the value of b. Okay, how you got 0. See what I'm saying now? Oh my god. Okay, you know, under opening of brackets, what we are supposed to do here is to compare the coefficients of both sides after you open the bracket. See now? Okay, so here after expanding, I've gathered the x squared. Okay, in fact, let me follow it sequentially so that I will not be jumping steps now. Okay, I've gathered my x squared. Okay, let's gather the x. So here x, bx and cx are carrying x. So let's put it together. Okay, Abigail, you are welcome. Alright, so we are going to have b plus c into bracket x. Remember that if you open this bracket, you still get back this. Okay, so then we now gather the constants, the one that do not have x. So here we'll have 2a plus c. So only 2a and c. do not have constant variable. Okay, so we can bring down this one, 2x squared minus x plus 3. Okay, so Loretta, you're welcome. So what's his name? Is that Patrick? Yes, Patrick, I'm trying to explain now. So you know what we usually do after we have expressed it this way, we now begin to compare the coefficients of both sides. So here the coefficient of x squared on the right is a plus b, while the coefficient of x squared on the left is 2, so it must be equal to 2. I can call this equation 1. Then I'll go to x. The coefficient of x on the right is b plus c, while the coefficient of x on the left is minus 1. I can call this equation 2. And then I will go to the last one. The whole of these are constants. So my constant, which is 2a plus c, is equal to the constant on the left, which is 3. So I can call this equation 3. Are you following me now? So, but I have gotten a and c. So no need bothering myself with this guy, because this equation only contains a and c. It will not help me achieve anything. Okay, all right. So the only place I have interest is in the equation that will help me get b, and that's the equation that contains b. My b is in the first and is in the second, so I can use any of them to get my b. And that's what I did here. I used the first one. Okay, so if you use the first one, which is a plus b is equal to 2, we already have the value of a as 2. So that's going to give us 2 plus b is equal to 2. Therefore, if you take this 2 to the other side, you get 2 minus 2, which is equal to 0. That's how I got the 0. Now, but like I was trying to say, another person may choose to use the second equation because it also contains b. Anyone you use, you still get the same answer. Let's try it. So if we use b plus c equal to minus 1, we already have our c, and our c is minus 1. See it here. Okay, so if we substitute it here, so we'll have b minus 1 is equal to minus 1. And so if I take this minus 1 to this side, it will turn to minus 1 and plus 1, and it will cancel this and still give me 0. Patrick, I want to get your response. Okay, Munachi has responded. I want to be sure that you've understood me up to this point, so that I will now explain what I did earlier on. Okay, you have understood it. Morgan, you are just showing up, or you have been here. Peculiar, Morgan, Chisom, Abigail, all of you came late, including Loretta. I owe you. You came late today. I will fight you. Okay, so let's go on now. So, Patrick, what I was now trying to say is that because you are looking, I'm just showing you what you will do to help you in exam, or even when you are solving normally. Because you are just looking for only b, so you will look for the relationship here that concerns b and leave the rest. So if I look at this place, there is b in x squared. So I can gather the x squared and compare its coefficient to the coefficient on the left hand side and use it to get my answer and move on. Leave this rest. You don't need them because you have already gotten your a and c. Assuming you have not gotten your a and c, then you will need to form these 3 equations. Do you understand that? Okay, I'm just seeing you now. Chibi came. Okay, so that's exactly what I was trying to say. Okay, so finally we have gotten our constants. So we will now come here and substitute. Okay, so let me remove this place. Okay, so if I substitute here, my a is 2, so it will be 2 all over x plus 1. Then plus, what is my b? My b is 0. See what will happen there. You know, I told you that your b can actually be 0, and the whole of this will go. So if this your b becomes 0, so this will disappear. So you have 0, and then your c is -1. So you have 0 minus 1 all over x squared plus 2. So that means our partial fraction is equal to 2 all over x plus 1. 0 minus 1 is -1. So you have -1 all over x squared plus 2. So here you can clearly see what I was saying, that the numerator of a quadratic denominator can also be a constant, but that will only happen when the coefficient of x is 0. So if the coefficient of x is 0, then it can still be a constant, but ordinarily it is supposed to be something like ax plus b. It should contain x, but if the coefficient of x is 0, then it can be a constant, no problem. Alright, so that's the solution for this first example. If you understood up to this point, make some noise. You can drop some emojis, you can respond, say yes, I understood, and the rest of that. Okay? Okay, so okay. Look at this example, and I don't know. Okay, let's look at this example. Let me call it example 2. We are given 3 all over x squared into x plus 2. What kind of thank you. What kind of even me too? I've understood it, sir. Okay. All right. So, what kind of partial fraction do you think this is? Which type? Do you think it is going to be distinct linear roots or quadratic? What do you think? Let me see your response or your view. Let me see your view. What kind of fraction do we have here? What type? We have discussed 3 types now. It satisfies at least one of them. Is it distinct linear or repeated linear or distinct quadratic? Let me hear you people. Pat, Morgan, Chibike, Lorita, Chisom, okay? Munachuku, alright? Your response. I'm waiting for you in this one. No? So, do you think this is supposed to be a distinct linear, a repeated linear, or a distinct quadratic? Okay, so what do you think it is? Nobody is saying anything. Be saying something whether you know what to say or not. I think it should be distinct quadratic because of the degree. Yes, distinct quadratic. Okay. Wait again. Monachi, what do you think? Loretta, what do you think? Alright, because of our time, distinct quadratic is correct. Why is it so? Just like Patrick said, the degree of x here is 2. And you cannot break it down into any other linear factors. If you break it down, it's going to give you x and then x again. Even though you can still try to do distinct linear actually by doing x and x squared, something like this. we can do a all over x, then do b all over x squared, then do c all over x plus 2. Okay, you can actually do that, or otherwise you can do these two. Okay, so which one is preferable? Okay, let's try these three. Let's treat it as repeated linear. Let's look at it. Okay, so let's see what it's going to give us. So our LCM will still be x squared into x plus 2. Okay, so here you are going to have x into this will be x, will give us ax, it will remain 1x, then x plus 2, then plus, bring down your b. Okay, I guess it's distinct quadratic. Okay, we'll come back to it, but let's treat it as a repeated linear. Okay, so if x squared divide, you have x plus 2. Then finally, if x plus 2 divide, you have x squared. Okay, now, so let's cancel the equal denominators. So we are going to have that 3 is equal to ax into x plus 2, then plus b into x plus 2 here, then finally c x squared. Okay, so let's try to solve. So if we want to get our a, what do we do? Okay, first of all, we can actually get our c first by eliminating a and b. And if we eliminate a and b, what do? We will say let our x be minus 2, because a and b have the same bracket. Okay, so that means we are going to, of course this is a constant, anything you put here it will still remain the same. Alright, is equal to, if you put minus 2 here, this will turn to 0. If you put minus 2 here, this will turn to 0. If you put minus 2 here, you get 4c, because minus 2 squared is 4, so that will give us 4c. So our c alone will be 3 over 4. Okay, so what's the next? We can try to eliminate a and c to get our b. How? By making our x to be 0. If we make our x to be 0, we are going to have, this will turn to 0. Of course, this will still be 3. So if you put x as 0 here, you get everything 0. If you put x as 0 here, you get everything 0. But if you put x as 0 here, you get 2b. So our b will be equal to 3 all over 2. Okay, finally, how do we get our a? Okay, a contains the two variables, so that's not going to work. So we can do expansion. All right, so let's quickly do expansion. So if we do expansion, we are going to have ax times x is ax squared, a times 2 is 2a. Then okay, Munachi said repeated linear. Okay, then let's go on. B times x is bx, and b times 2 is 2b, then plus cx squared. All right, so what's that going to be? So remember, we are looking for only a now. So the one that consign a is x squared and constant. Okay, so we can use x squared or constant. So if we use constant, so what is it going to be? So we can use constant. 3 is equal to, the only constant here is 2a and 2b. And so our constant on the left hand side will be equal to 2a plus 2b. Okay, so and that's going to give us, okay, so let's substitute. We already have the value for b. So what is our b? Our b is 3 over 2. So we are going to have 2 times 3 over 2. Okay, so 2 here will cancel this 2. So we'll have 3 is equal to 2a plus 3 is remaining here. So this 3 coming over here will be 0. So you have that your a is equal to 0. Okay, so I just used only constants to do it and I got 0. Let's use x squared to check if we get the same 0. If we use x squared, so that will be a plus c, because it will look like this, a plus c into x squared. Okay, I hope there is no error anywhere. Okay, all right, let's see. So that's going to give us, on the left hand side there is no x squared, so that means our a plus c is going to be equal to 0. So we already have our c as what? As 3 over 4. So that means we have 3 over 4 equal to 0. And so our a is minus 3 over 4. Okay, so clearly you can see here that the two of them are not the same, which is not supposed to be. Both of them are supposed to be the same. So what does that mean? It simply means that this is not supposed to be repeated roots. It's not supposed to be repeated denominators. So it's actually supposed to be distinct distinct quadratic. Okay, so let's go back to it. Okay, which one did you not understand? Let's go back to, don't worry, it's supposed to be distinct denominators. So I purposely did that so that we will see it. Okay, so if we use distinct denominators, what that is going to give us is that we have x squared into x. Is it x plus 1? Sorry. Okay, x plus 2. Okay, so this is supposed to be a, or let's first of all split the bracket. Okay, so let's put x squared here, and let us put x plus 1 here. This is 2. Is it 1 or 2? I removed it. It should be 2. Okay, Loretta, we are doing it as a distinct quadratic. So don't worry, you follow now. Okay, so this is x squared and then x over 2. Okay, so because we shouldn't have splitted this, because it's just 1x and it is square. So that's why I said it is distinct quadratic. But we just say let's try repeated linear. So let's go ahead. So here, because this is quadratic, we will have ax plus b. Then here is linear, so we have only c. Okay, so then we can now look for LCM. I said I don't want this class to pass 1 hour. Can I pause this lesson here and we'll continue it in the next class, or let's just finish it? Okay, so should I okay, let's pause it here. Just keep this example. We will start this example in our next class, and I'm going to let us know when we are going to meet in the next class. Sir, in the expansion I thought it is 2ax. Okay, maybe I made a mistake there, and I wanted to leave that to check if there is any mistake. Where is it, Seth? Oh, okay, like I said, let's leave it. When we come tomorrow, or we will agree in the group chat when next we are going to meet, and then when we meet, then we will discuss. Maybe tomorrow evening we will start with this example and we'll consider the two of them again, so that I can check this mistake. Maybe I made a mistake somewhere where Monachi is pointing out. Alright, so this is where we will likely end for today. Okay, we'll likely end here for today. So have a very good night, everyone. Please, if you have not subscribed to the channel, do so. And then if you did not write your attendance for today, also do so. None of you did, actually. And then also, before you leave, please like this video before you leave. Okay, and then I want to beg you also, when you finish, when I end this video, please come back. That your thank you, sir. Come back and type it, because if you type it on this live chat, it will disappear. and it doesn't look good. So after the class, so that when people see this video later, they will know that the people that participated in the class understood it. All right, so what you will do is that after the class, once I end the video, you come back and yeah, Patrick, this is your thank you and God bless you. Thank you very much. But once I end the lesson, you come back and type it again. It's very important. Okay, a very good night everyone.
अस्सलाम वालेकुम, कैसे हैं आप लोग? उम्मीद करता हूँ आप सबके सब जो हैं बिल्कुल खैरियत से होंगे। तो आज